Today, we'll be solving LeetCode 160, intersection of two linked lists. This is a classic linked list problem that really tests our understanding of how to traverse and manipulate these data structures. The problem gives us the heads of two singly linked lists, and our goal is to find the node where these two lists intersect. An intersection means that at some point, the two lists share the same node, meaning they become one list from that point onward. If there is no intersection, we simply return null. The challenge is to do this in an efficient way, and there's a very clever two-pointer solution that we can use. Let's think about the challenge. The two linked lists might be of different lengths. If we start a pointer at the head of each list and move them forward one step at a time, they might never arrive at the intersection point at the same time because one list is longer than the other. We need a way to somehow synchronize their journeys. The brilliant idea behind the solution is to have each pointer traverse both lists. Specifically, pointer A will traverse list A and then switch to list B. Pointer B will traverse list B and then switch to list A. By doing this, each pointer will cover the same total distance by the time they meet. If the lists intersect, they will meet at the intersection node. If they don't intersect, both pointers will eventually become null at the same time, after having traversed both lists. We first initialize two pointers, let's call them pointer A and pointer B, and we set each of them to the head of their respective linked lists. Then, we enter a while loop. The condition for this loop is that pointer A is not equal to pointer B. Inside the loop, we need to advance each pointer. For pointer A, we check if it has reached the end of its current list. If pointer A is not null, we simply move it to the next node in its list. However, if pointer A has become null, meaning it has finished traversing the first list, we then set it to the head of the second list. We do the exact same thing for pointer B. If pointer B is not null, we move it to its next node. If it has become null, we set it to the head of the first list. We continue this process of moving the pointers and switching lists until pointer A is equal to pointer B. At that point, we break out of the loop. The node they are both pointing to is either the intersection node, or it is null, meaning there was no intersection. We then simply return that node. The reason this works is because by switching lists, each pointer effectively traverses the entire length of list A plus the entire length of list B. This means the paths they take are of equal length. Therefore, if there is an intersection, they are guaranteed to arrive at that node at the exact same time. It's a beautifully symmetric solution. Now, let's discuss the time and space complexity. For time complexity, in the worst case, each pointer will traverse both lists once. So, if the length of list A is m and the length of list B is n, the total time complexity is O of m plus n, which is very efficient. For space complexity, we are only using two pointers, which is a constant amount of extra space, so the space complexity is O of 1. And that's how you solve LeetCode 160. Thank you for watching and let's keep learning.